Equivalent fractions, if you don't already know this, are fractions that are equal to one another. Equal fractions. That's what equivalent means. Equivalent means equal. So the pictures I have here, I'm showing you, is just a couple examples of equivalent fractions. Right here you'll notice this is a model of 2 6. Here's 2, and the whole thing is 6. And that is exactly the same as 1/3. There's no difference. If you look at the purple portion there that's shaded in, they're exactly the same size. The only difference is the way they're being expressed, the way they're written is different. But 2 6 equals 1/3. Same thing down here. What we have here in our first example is we have 3/5. And 3/5, if you look at the shaded blue part, it's no different than over here. Now what do we have? We have 6/10. Okay, so it doesn't matter, if you think about it, it doesn't matter how big or how small the numbers are in a fraction. Equivalent fractions are equivalent because they have a same common factor, and we're going to get into that next. But this is just a picture showing you why fractions are equal, like what they look like. Let's go ahead and factor, either by multiplying or dividing by the same number. Now this diagram I have here is we are starting with 3/4, and I just want to show you why 3/4 is equivalent or equal to 6/8, to 9/12, and to 12/16. And it all comes down to you're using the same multiplier. Okay, so sometimes you multiply by 2 and you get 6/8. So let's go ahead and talk about that now. 3/4, this is, I would say, the simplest form of 3/4. This is, you know, we cannot break this down any further into any smaller parts. Okay, but there's 6/8. 6/8, if you notice, 6/8 and 3/4 are no different. 3/4, 6/8, exactly the same blue part that is shaded in. Okay, only difference being is that we multiplied by 2. Okay, we didn't multiply the fraction by 2. You know, when we multiplied, let me go back. When we multiplied by 2, we multiplied the top by 2 and the bottom by 2. And I know we haven't gotten into multiplying fractions yet, but it doesn't hurt to say that when you multiply the top and the bottom by 2, you're basically like multiplying it by 1. And what's anything times 1? You know, 8 times 1 is 8. 17 times 1 is 17. Okay, so when you multiply by 2 over 2, 2 over 2 equals 1. 3 over 3 equals 1. So you're essentially multiplying by 1. Okay? So when you multiply by 2 over 2, okay, we're multiplying by 1, but we're just expressing it differently. That's all we're doing, is we're expressing it differently. So 3 times 2 is 6, 4 times 2 is 8. Okay? So that's what we got there. Okay, now let's say we take 3/4 this time and multiply by 3. Okay, what's important about equivalent fractions is that you multiply the top and the bottom number, the numerator and denominator, by the same number. So when you multiply 3 and 4 by 3, you get 9/12. Okay, there you go. Now look, I'm just going to go back and forth here, and you'll notice 9/12, 3/4 are exactly the same thing. This part of the whole, this fraction strip I'm showing you there, is exactly the same whether I show it this way or this way. It's all the same. Okay? It's very important though that when you multiply by a common factor that you use the same number. I can't use 3 up here and then let's say I use 10 down there. I've got to use the same factor. 3 and 3, 2 and 2, 7 and 7. The next one here, let's say we're multiplying by 4. And hopefully you get the picture by now, but you know, I'm going to multiply the top by 4 and the bottom by 4. Okay? 3 times 4 is 12. 4 times 4 is 16. And now when I multiply by the factor of 4, I should get 12/16. I should get 12 here, 12 in the blue region, the shaded blue region, and in the, well, not in that part, but in the entire region I should have 16 parts. So there you go. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 out of 16. I'll just keep going here. There you go. So 12/16. Now that's equivalent fractions. Now equivalent fractions, just to say it again, just so you remember, equivalent fractions are made by multiplying or dividing by the same common factor. Okay? Alright, now let's go ahead and start making equivalent fractions. Let's pretend we have, let's say we have limited information, just enough information to figure out what the missing denominator is. We don't know what this number is. Okay? We want to figure it out. Now let's use what we know about equivalent fractions to figure that out. Now we just got done talking about how equivalent fractions are made by multiplying by a common factor, by the same factor. Well, let's look at the denominators here. And that's your first hint. Okay, look where there's two numbers that you can compare. How do you get from 6 to 30 by multiplying or dividing? And in this instance, we're going to multiply by what? 5. Okay, so the rule of equivalent fractions states that we must multiply the top and the bottom by the same number. So we're going to multiply the top by 5. Not put 5 here. We're going to multiply by 5. So 5 times 5 is 25. Equivalent fractions here. Why don't you go ahead and pause the video, try these out on your own, figure out what the missing number is, the missing value in each numerator, and then check your answer in a little bit. 3, and this one by 3. 3 times 3 is 9, and 2 times 3 is 6. So that number should be a 6 right there. 2/3 is equivalent to 6/9. On this one right here, you're going to multiply by 4. 3 times 4 is 12. So that should be 12/16. On this one, you're going to multiply by what? You're going to multiply by 6. So 1 times 6 is 6. And this is one of the instances where you actually put that factor there of 6. A lot of times, here we multiplied by 4, but we didn't put 4 there. Here we multiplied by 3, but we didn't put 3 there. We're putting a 6 here, though, because this is a 1. Okay? And that's when that occurs. But that doesn't happen every time. This has to be a 1 in order for that factor to go there. 10 times 6 is 60, so I'm going to multiply 8 times 6. That is 48. Okay. Now let's talk about reducing fractions. Now reducing fractions is just another way of making equivalent fractions. But this time, instead of multiplying, we're going to divide. Just another way of showing equivalent fractions. In a lot of our previous examples, we were multiplying. We were using a common multiplier, like multiplying the top and the bottom by 2, or multiplying the top and the bottom by 3. But when we reduce fractions, we typically divide by a common factor. So I'm going to look for, and I'm not really going to talk about greatest common factor yet, or least common multiple. I'm not going to use those terms yet, because we're going to get to that to a later date. But let's go ahead and just, figure this out. So I'm going to divide by 2. I know that those are both even, so I can divide by 2. Now I know some of you are probably thinking, I can do this faster, but I'm just going to show you kind of a typical way of doing it. So I got 12/15. When I divided 24 by 2, I got 12. When I divided 30 by 2, I got 15. And I'm going to keep on dividing by a common factor until I cannot think of any more factors. So this time, I'm not going to divide by 2 because I have an odd number in there. So I'm going to divide by, let's say I divide by 3. Okay, and 12 divided by 3 is 4. And 15 divided by 3 is 5. And that's it. That is in simplest form. And that is it. That is in simplest form. You cannot go any further. Okay, this next one here, we have 15 and 21. We're going to try to think of some numbers that we can divide into 15 and 21. Well, here's what you don't do. Don't divide the top, let's say, by 5 and the bottom by 7. I know those numbers divide into 15 evenly and 21 evenly, but the problem here is that you're using a different factor. We can't do that. We have to use a common factor. Don't count out 3. 3 divides into both. So 15 divided by 3 is 5. 21 divided by 3 is 7. So there you have it, 5/7. Here's another one. 36 divided by 60. Now if you can think of a bigger number, go ahead and use it. I'm going to use 12. So 36 divided by 12 is 3. 60 divided by 12 is 5. And check it out, I got my answer right away. 3/5 is in lowest terms. You cannot simplify that anymore. Okay? If you didn't think of 12, you can think of any number as long as it divides into both. So let's say you started with 2, which might be a typical response. So half of 36 is 18. Half of 60 is 30. And I'm going to divide by 2 again. And half of 18 is 9. Half of 30 is 15. And then I can't use 2 anymore, so I'm going to use 3. 9 divided by 3 is 3. And 15 divided by 3 is 5. So you get 3/5. So as you can see, it doesn't really matter how you do it. Whether you start with a nice big number like 12, that's a common factor of 36 and 60, or you start with some smaller numbers like 2 or 3. Either way, as long as you get it into simplest form, that's all that matters. Okay, so that concludes our lesson on equivalent fractions and reducing fractions. Go ahead and make sure you fill out your notes completely, and I'll see everyone tomorrow. Have a great night.